Hey guys, so today we are going to be graphing our square root and cube root functions. So we're going to start with our radical functions today, and radical just means that it has, let me find my pen, this symbol in it. So we know that's our square root, and then here we have the cube root, and this is called a radical. So anytime you hear me refer to what's underneath the radical or anything like that, that's what I mean. So with our square root function, we all know what a square root is. And with our parent functions, it's just when we have y equals and then something plain with an x. So that means y equals the square root of x. And I'm sure we've all seen this before, but maybe not have studied into it. So with our y equals the square root of x, if we needed a table of values to help us out, we've got our x's, our inputs, and then our y's. So I like to start with negatives and then go into positives. The square root of 0 is 0. So if I input a 0 for x, I'm going to get a 0 for y. So I know I'm going to have a point there at the origin. The square root of 1, so this will be square root of 1, which is 1. So I'll have a point at 1, 1. Square root of 2 isn't a clean whole number, so we're going to skip that one. And the next square root that I know will give me a good clean whole number is 4. So if I plug in a 4, I get the square root of 4, which is 2. So we're going to go to 4 on the x and then 2 on the y. The next one that I can do is a 9, and the square root of 9 is 3. So we'll go all the way over to 9 and up to 3. So we kind of see what the curve's looking like, and then let's look at our negative values. So if I tried to do the same negative values, let's say I did the square root of -1, we run into a problem. The square root of -1 is an imaginary number, and I can't put that on my regular xy graph, my coordinate plane. So let's look at -4. So with the square root of -4, we run into the same issue. We've got a negative underneath that radical, which means this would be 2i. And I can't place an I on my xy plane. So when we're graphing the square root parent function or any transformations of it, we see that we're going to start at 0, 0, and then we're going to curve to the right. And we're not going to have anything on the left. Now, if we have a transformation that moves us to the left, then that's fine. We will move away from the origin when we've got our translations and things like that. But when we're starting with the parent function, we'll always start at 0, 0 because that's my endpoint. Then for my domain, remember domain are my x values. And so my x's start at 0. And they go to the right forever, so they're going to head toward positive infinity. And then my range is starting at 0. And it looks like it's increasing and then it's going to kind of flatten out, but that's not true because my next one, let's see, would be 16, which would bring me to a 4. 25 would bring me to a 5. And so I'm going up incrementally by 1, but on the x's, they are going to spread out a lot. But my y's will continue going up, so they will head toward infinity as well. It's just going to be a very slow rise on the y-axis. So I've got my domain, my range, and my endpoint for the square root parent function. So because those are imaginary numbers, we're not going to put them on the xy plane. Now with our cube root, we have y is equal to the cube root of x. So let's make our little table again. We're going to plug in an x and get a y. Let's start with 0. So the cube root of 0 is 0. So we've got a point here. the cube root, not 0 again, the cube root of 1 is 1. So again, we have a 1, 1. I can't take the cube root of 2, and when I say I can't take it, that just means that it's not going to give me a whole number, it's going to give me some long decimal. And I don't want to have to graph some long decimal because it won't be accurate. So we like to have whole numbers as our answers, and if you have to play with it on the calculator and say, okay, what's the cube root of 2? No, that's a decimal. What's the cube root of 3? No, that's a decimal. That's fine. The next one where I can get a whole number out of it is 8. And the cube root of 8 is 2. So we'll go all the way over to 8 on the x-axis and up to 2 on the y-axis. So it's looking a lot like the square root parent function, but it is lower. And by lower, I mean it's not going up to 3 on 9. Then let's look at the same values, but negative. The cube root of negative 1 is negative 1. So if you don't believe me, plug that into your calculator and see what it gives you. And then the cube root of negative 8 is negative 2. So we'll go all the way over to negative 8 on the x-axis and down to negative 2 on the y-axis. Now I'm going to connect these. Oh, I missed that point. So I've got my x's, my y's, and then the curve in there. My turning point. So we see that here we are increasing, and then we reach a point where we're decreasing. So when it says turning point, it's saying where does that switch happen? And for the parent function, it's at 0, 0. Of course, with any translations, it is going to move. Then our domain, all of our x values, will be all real numbers. And then our range as well, we're going to go infinitely smaller as we go to the left, and then infinitely greater as we go to the right. So this y will keep going up like that, and then this y will keep going down like that, and it will be a steady decrease and increase. Now, when we have our transformations, it's going to look like this funky looking thing right here. F of x equals a times the nth root of x minus h plus k. So this is just like our transformations when we've done quadratics and when we've done our linear functions as well, and our cubic functions. So the transformations will look the same. A on the outside is the number that's multiplying, h on the inside moves us left and right, k on the end moves us up and down. So h is the horizontal shift. So plus h, remember on the inside we go opposite. So our h's are opposite. So a plus h will shift us left, and minus will shift us right. So it's the opposite with our h's. And with our k, it's as is because k is vertical. And so a plus k will move us up, and minus k will move us down. The end point or turning point will be negative h comma k. So that's just like when we were doing our quadratics, that our vertex was negative h comma k. Well, I shouldn't say negative h. It is hk, but we're going to take the opposite of what we see because this in here. But it is just h, so just the value of h. If a is negative, the function is reflected across the x-axis. If a is greater than 1, that represents a vertical stretch. So that's the one that is pulling our graph higher and lower. And then if it is a fraction, that is a vertical shrink. So that's the one that I told you to think of a cartoon getting bopped on the head with a hammer. So on each of these examples, we're going to describe the transformations and then compare it to, well, the transformations compared to the parent function, sorry. Can't read. So on number 1, I want to know what is my parent function. So my parent function is y equals square root of x, since there is no number right there. So it's just the square root of x. And so compared to that, I see this change here and this change here. So my first transformation will be a horizontal shift to the right, because it says -7 and we're on the inside, 7 units. So remember, inside is opposite. And then +2 on the end is a vertical shift up 2 units. So on the outside, we take it as it is. On number 2, we have the cube root of x. So my parent function is different from number 1 because of this guy right here. So I see a change here and here. The 4 on the outside is a vertical stretch. So we're pulling that function like a rubber band. It's a vertical stretch by a factor of 4. And then -1 on the end is a vertical shift. So that's like sliding the graph. And we're sliding it down 1 unit. On number 3, I see this guy right here, which means my parent function is the cube root of x. Now comparing to that cube root of x, the changes I see happen right here and right here. So that first one, that minus sign in front of the radical, is a reflection across the x-axis. And then that +3 on the inside is a horizontal shift to the left 3 units. Number 4, it looks like we've got a lot going on, so we're going to unpack it one piece at a time. First, I don't see anything right here, so it is a plain square root of x as my parent function. So compared to that parent function, I see this 1/2 here, this -2, and this -6. So 1/2 is an a value, and it is a fraction, so it is a vertical shrink. By a factor of 1/2. -2 on the inside, we think opposite, so that's horizontal shift right 2 units. And lastly, that -6 on the end, we take it as it is. It is a vertical shift down 6 units. So we'll move on to the next one. The square root parent function is reflected across the x-axis, then shifted 7 units left and 1 unit down. And we're going to write an equation that represents this function. So we got reflected across the x-axis, shifted 7 units left, 1 unit down. So those are my transformations. My parent function, my parent function is y equals the square root of x. And so my new function, I'll name it f of x. So it's reflected across the x-axis, which I know will be a minus in the front. There is no stretch or shrink, so I'm going to go straight into writing my radical. We're shifted 7 units left, so we go opposite, so plus 7, and 1 unit down. On the outside, we have a minus 1, so be careful not to write it underneath that because it's not the same. So we need to make sure that it's on the outside of that, of the radical. Now number 6, a cube root function has a turning point located at -2, 3. Write an equation that could represent this function. So this one is a little bit more difficult. We only know the turning point, but I know it's a cube root function. So my parent function, so the function before any transformations happened, is a cube root function, so the cube root of x, and that has a turning point of 0, 0. So if I have a turning point at -2, 3, that means I shifted left 2 and up 3. So remember, my x-axis is my left-right movement, and then my y-axis is my up and down. So that's where I got the left 2 and up 3 from. If you have to sketch a graph off to the side and count, that's fine. Count that you went left 2 to get to -2, and you went up 3 to get from 0 to +3. And so my new function, we don't have a reflection, so there's not going to be a negative in the front. We don't have a stretch or shrink that was mentioned, so we're not going to have an a value in the front. So it is a cube root function that was shifted left 2 and up 3. Now in this next part of the notes, we're going to graph each radical function. So in order to graph, the easiest way to do this is to write out what our transformations are, because I know what the parent function should look like, and if I can just scoot it over to the left, scoot it over to the right, then that's going to help me to graph. So what I'm going to do on each of these is sketch out the parent function on the graph first, so I can count over any of my transformations that are occurring. The parent function is on the graph, and I wrote out to the side the transformations. So since we have that +5 on the end of them, on the end of the function, it's going to take us up 5 units. And it looks like that's the only transformation that I have. So I'm going to take each of these points and move them up 5 units. And besides that, the function should look identical to the parent function. So it's like if you could pick up the parent function and just move it up 5 units, that's what the new function would look like. So the domain, still my x values, start at 0. And so going left to right, and first point is 0, and then we move to the right infinitely. And then my range. Now my range will change because I'm shifted vertically. So I moved up 5 units, so now my range doesn't go all the way down to 0. Now it only goes down to 5. And it will still continue to go up toward infinity. The end point, I don't have a turning point. Get an end point on my square root functions. The end point of this one is 0, 5. And my end behaviors, as x approaches infinity, f of x is increasing. And as x approaches negative infinity, so if we're going from the right to the left, we are decreasing. We are increasing between 0 and infinity. And then decreasing, we're going to say NA, because we don't have any decreasing values unless we switched that interval and said, well, if we're looking backwards, but that's not how we write our intervals. So we would just say that we are not decreasing on any of this function. Now with the next one, I'm also going to graph the parent function real quick and write out the transformations. So on number 8, we have a horizontal shift to the right 1 and a vertical shift down 4. So we are taking these exact same points from the parent function, and we're going to move to the right 1 and down 4 units. And then connect them. And again, that's like if we could pick up the parent function and just move it down 1 and to the right 1, right 1 and down 4. And so our domain, our x values do change because we did have a left-right movement. So we moved to the right 1, so my domain is now 1 to infinity. My range will change as well because it's no longer starting at, well, bottoming out at 0. Now we go all the way down to negative 4 and still head toward infinity. We've got an endpoint because this is a square root function, and that endpoint occurs at 1, negative 4. And behaviors, so as x is approaching infinity, f of x is still increasing. And then as x approaches negative infinity, we are decreasing. So if we're looking from the right to the left, our function is decreasing. So our increasing interval, we start at 1 and head toward infinity. And again, we don't have an interval where we are decreasing. On number 9, we'll do the same thing. I am going to change this problem, and I'm going to graph the parent. So the original number 9 had 3 times the square root of x plus 1, but I am changing that to the cube root of x plus 1, just because we haven't had an example yet with a cube root. So the transformations from the parent function will be left 1 unit, and I went ahead and graphed the parent function. So we are going to move each of our points left 1 unit. So if I'm only moving them left 1, then their y values are not changing, so just be aware of that. And then I'm connecting all these purple ones. And that is my new function, so it's like taking that graph, picking it up, and saying I'm going to move this over just 1 to the left. So my domain, negative infinity to positive infinity, same for my range. We're going to cover every value possible. And on a cube root function, we have a turning point. And that turning point used to be 0, 0, but we moved it to the left 1, so now it's negative 1, 0. So as x approaches infinity, so as x is going this way, f of x increases. As x approaches negative infinity, so as x goes this way, we're decreasing. And so we're increasing on the interval negative 1 to infinity. So from that turning point to the right. And then we're decreasing from the left to that turning point of -1. So then for your homework, you have these 6 problems to do. First 2, you're describing the transformations, and then on 3 and 4, you're writing the equation when you're given the transformations, and then on 5 and 6, you're going to write your graph out. There should be a line there and there, so if you need to draw those back in, that's fine. It didn't pick up on the copying. So here are the notes, and that is everything for graphing our radical functions. And then I will see you guys tomorrow for cubic functions.